Your father left this in my possession before he died. It is time it was returned to you. Use it well. What is it? Some kind of cloak.
Well, let's see then. Put it on. Whoa! My body's gone. I know what that is. That's an invisibility cloak.
Well, I hope you guys enjoyed the clip. Now we're going to talk to you a little bit more about invisibility.
The whole idea of invisibility is structured around the ideas of refraction and reflection as it concerns light waves. The idea is that if light can be refracted around an object by use of prisms of something or of the sort, one could see not the object they are looking at, but the object directly behind it. Similar to how people see images behind glass. The idea of refraction is such that when light is doubly reflected through the glass, there's little change in direction, and therefore the waves exit with the color and image of the image right behind it. So it seems as though the glass is completely invisible.
And scientists have been hypothesizing about invisibility for as long as we know, for practical uses such as hunting or military use. But so far they have failed to produce fully invisible cloaks or invisible men. The closest we are able to get is camouflage. And now we're going to show you a couple more clips about where modern technology is today regarding technical invisibility.
It was once something that belonged only to science fiction, but now Japanese researchers have created technology that's the first step towards making objects invisible.
The technology comes from 2003, but its developers say the Harry Potter-like invisibility cloak is just the beginning. The team, led by Dr. Susumu Tachi from Keio University, is now adapting its findings to help pilots, drivers, doctors and others. Retroreflective projection technology uses a computer, a video camera and projector to shine background images onto the front of a subject wearing specialised clothing, creating the illusion of invisibility. What makes the technology unique is a fabric made of glass beads only 50 microns wide, which can reflect light directly back at the source, much like a movie screen. Viewed from near the light source, the projection is bright even in broad daylight, and researchers say the material can be applied to almost anything. In the short term, the team sees usage in car interiors, airplanes and helicopters. They say blind spots could be eliminated and accidents and hard landings avoided by making walls seemingly transparent. The eventual goal, though, is to create an augmented reality that allows anyone to easily see information on real-world objects.
Looking to the future, instead of glasses, people could wear this, and it would act as a navigation system. It could also tell you who someone is if you meet them around town.
In the few years since the technology's invention, the price of the material, as well as that of computing, has come down, opening the door for smaller yet more powerful applications. Whether used to increase safety or to create a whole new form of computer-human interaction, the world is likely to see, or possibly not see, more of this technology in the future.
Now you see it, now you don't. Well, almost. A new so-called invisibility cloak called Adaptive has been tested, which could one day help military vehicles blend into their surroundings and avoid heat-seeking missiles. So, how does it work? Well, this cloak is basically a sheet of hexagonal pixels that can change temperature very quickly. Onboard cameras can pick up the background scenery, then display that infrared image onto the cloak, allowing even a moving tank to match its surroundings. The maker's BAE Systems say a vehicle can also pretend to be something else. For example, here on the left, you can see a tank with Adaptive off. Then on the right, you can see it with the technology on, and it's mimicking a car nearby. This, the company says, will reduce the chances of it being attacked. It apparently works both in the day and night, and when the vehicle is moving. When we spoke to the company, they admitted it's not 100% invisible. The outline can be seen by the naked eye. But they told us the main advantage of the technology is that it confuses heat-seeking missiles. They said it could be in production in 2 years' time and could one day be used to cloak battleships at sea.
So the last few examples we gave you weren't exactly about refraction like we had spoken about, but they did have relevance to invisibility because it involved reflection of light and differences in pigmentation, which still involve the changing of an image and the appearance of that image.
However, there have also been numerous advancements in the refraction of electromagnetic waves, which now we will have a clip of Dr. Michio Kaku, and he will expand on that a little more.
If I was invisible, could you see me?
No, by definition. And 2 years ago, we thought it was impossible to get invisibility. In fact, in my optics class at the university, I would tell my students it's impossible for light to bend around an object, reform at the other end. Well, I was wrong. Every single physics textbook on the planet Earth is wrong. 2 years ago, it was done at Duke University. With microwave radiation, they took an object, they showed that you can bend microwaves around an object, have it reform on the other side as if it's not there at all. And then at Caltech, just 6 months ago, we did it with visible light. Now think about that. We can now take, in principle, an object and make it disappear just like in the movies. So Harry Potter, watch out.
The invisibility cloak is a real thing that's going to happen?
A cloak is hard. However, we do think that an invisibility cylinder is possible within a few decades.
That's not as sexy as the cloak.
Hey, you know, get used to it. This is physics we're talking about. This is reality. A cylinder, you could put a soldier inside.
Right.
And of course, guess who's funding this research? The Pentagon. The Pentagon is not stupid. They know the enormous advantage if you have invisible soldiers, invisible helicopters, and what have you. If you have a cylinder, the person inside will be invisible because light will wrap around it like water going around a boulder. Wow. Downstream from a boulder, you have no inkling that there's a boulder upstream because water has reformed on the other side.
Dr. Kaku brings up an interesting point in the fact that in a couple of decades, we might be able to create a cylinder which would render a soldier or some kind of object completely invisible. The idea of this is pretty intense considering that if invisibility were to become even more efficient, privacy laws would need to be altered, national securities would be in upheaval, not to mention the severe flux of funds and enrollment in the field of optics.
And not only that, the idea of invisibility is very humbling because we can see that the laws of physics are never changing. They still remain exactly as they always have been. we know the law of refraction, the law of reflection, they're still the same. Man is just manipulating them to create what was formerly regarded as an impossibility a reality.
And this is just another example of the limitless possibilities of man's knowledge, especially of his surroundings, which ultimately gains humanity a much better grasp of the mysterious force known as physics.